Okay, hello, I am Snow, and today, right now we're gonna talk about points, lines, and planes. Points are in an exact location on a given plane, and you can name them two ways. You can just name it A, or you can call it point A, like so. Okay. And then we have lines, which go infinitely in both directions. And you can name it, 2 points on it. And you can call it line A, B. Call that line A, B. Or if it's like a name on. There's already a name for it, like so, like the L right there. You can call it line L. And then there's multiple different types of lines. We have rays, which stop at one point and go opposite, and they go infinitely in the opposite direction. We also have line segments, which are 2 dots, 2 points, and a line in between them. So that's fun. Then we also have planes, which look like this. Ta-da. And they have 3 points. So it would be ta-da, ta-da, ta-da. And you can call this plane A, B, C. So, ta-da. And that's all. 4 points back. Okay. So now we're going to talk about parallel and perpendicular lines. Now we have 2 theorems for them. For parallel, just going to call them parallel. Yeah. Their theorem is to where we have 2 lines, and they never intersect at all. The slopes are exactly the same, but the y-intercepts are the only thing that are different. Perpendicular lines, let's give their theorems. They intersect at one point, and they form a right angle, like so. Now for them, the slopes are different, and so are the y-intercepts, but see, for perpendicular lines, like let's call this, the slope is A, B. The other line's slope would be negative B over A. It's the opposite reciprocal of it. And they're easy to find. For parallel, just the same. Perpendicular, you just find the negative reciprocal of the other one. Okay, so now I'm going to talk about distance. And here you can see the formula for distance, which is d equals the square root of x2 plus x1 square that minus y2 plus y1 and you square that, and then you find the square root of the total of that. I need to try somewhere. Okay, so I have an example for us, and it's just right there. 6, 4 with 10, 8. So I'm going to label this our x1 and y1 and x2 and y2. Ta-da! Okay, we just plug in the numbers. Okay, we add these. Okay. And then just to find the square root of 112, you can just put that in your calculator. And that should equal, and the distance should be about like 10.6 or so. Yeah. Now we're talking about proving lines are parallel. And you can do that by seeing if the slopes are the same. But if it's not possible to find the slopes, and they give you the measures of the angles, of certain angles, it's possible as well. Like, if they give you this angle measurement of these two angles, which would be called the same side exterior angles. And if they are the same or congruent, then you can find, then that's one way to prove them. Or if they give you the measurement angles of these two angles, those would be the same side exterior angles. If those two are also congruent, then your line is parallel. But let's say they give you the measure of this angle and this angle. That'll be alternate exterior angles, and those two angles should equal 180. But let's say they give you the angle measure of here and here. Those would be alternate interior angles. And if those also equal 180, then your two lines should be congruent, or not congruent, but parallel.
Hey guys, Enda here, and thank you for watching the video. I hope you guys liked it. If you have any suggestions, leave it in the comments below. If you could, subscribe, like, comment. And first, before I end the video, I'd like to thank everybody who helped, who was in the video, who was part of the video. First of all, I'd like to thank Snow, my partner. She does not want to be seen on camera. She was the person doing most of the talking in the video. All I saw was her arm. Secondly, I'd like to thank Ms. Stevenson for giving us the opportunity and chance to do this. Video, and just big shout out to her. Thank you, and that's all I have for you to do later. And see you next time. Bye.